Hi guys, so today we're going to learn how to solve systems by substitution. In the last lesson, we saw how to solve it graphically. In this lesson, we will solve by a method known as substitution. Okay, it's a very important technique and we want to become very good at it. And what it boils down to is one of the most important properties of equality, that equal things or equal expressions can be replaced or substituted with each other. Okay? So here are the steps. Step 1, we're going to isolate a variable. So we're either going to get x or y by itself first, if it isn't yet. Okay. The tip is to try to pick a variable that has a coefficient of 1. So actually, I shouldn't say no coefficient. We don't see it, but it's a coefficient of 1. Okay. Once we do, we're going to substitute it into the other equation and solve it. And then last, we're going to back solve for the other variable and check our answer. Okay. So here I have my first system, y equals 2x plus 1. And then the other one here is 3x plus y equals negative 9. So step 1, I want a variable by itself. Okay. So here I actually already have that, right? So y equals 2x plus 1. Y is already by itself on the left side. Okay. So I can move on to the next step. What I'm going to do now is I'm going to substitute it into the other equation and solve. So what I'm going to do is I'm going to take this and replace the y in the other equation with it. Okay? So I'm going to take the 3x plus y, but instead of writing y, since we know that y is 2x plus 1, I'm going to substitute in 2x plus 1. Okay. Then, this is the same as saying 3x plus 2x plus 1 equals negative 9. Okay, and then after that, we're just solving for x. So 3x plus 2x is 5x. I'm going to get rid of the plus 1 by subtracting 1 on both sides. So 5x equals negative 10. Okay, and then get rid of this times 5 by dividing by 5. And I get 1x equals negative 2. Okay. And then once I have that, all I need to do is I'm going to take this x equals negative 2, and I'm going to plug it back in. It technically doesn't matter which one you plug it in, but since this already has y by itself, I'm going to plug it into this one, and I'm going to plug it in right here. Okay. So y equals 2 times, I know x is negative 2, so I can substitute it in. Right? And then I'm going to solve. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. And so my solution is negative 2 comma negative 3. Okay. If I want to check my answer, nice and easy. We did that before. We can just plug this x and y into both our originals. Right? So I can do that with negative 3 equals 2 times negative 2 plus 1. Negative 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. Okay, so it works for the first equation. Okay, and then I can check it with my next one. So 3 times x is negative 2 plus negative 3 for y equals negative 9. 3 times negative 2 is negative 6. Plus a negative is same thing as minus. Negative 6 minus 3 is negative 9. Does negative 9 equal negative 9? Yes, it does. And I can see here that it is true for both of my equations. So negative 2, negative 9 is my solution. And we write it as an ordered pair, as x comma y. Okay. So let's keep going. Okay, so here is my next one. Okay, so I have 3x minus 4y equals 28. And x plus 2y equals 6. So first, I want to isolate a variable. I either want it to just say x equals or y equals, okay? And the tip, again, is to try to pick one where there is a no coefficient, or technically, it does have a coefficient. It's a coefficient of 1, okay? So what I'm going to do is I'm actually going to pick this one here, the bottom one, x plus 2y equals 6, because this has a coefficient of 1, right? So really, it should be coefficient of 1. Right? Because this is 1x plus 2y equals 6. Versus this one has 3 or negative 4. I would have to get rid of it by dividing. Okay? So I'm going to take x plus 2y equals 6. I'm going to solve for x by subtracting 2y. Okay, so x equals negative 2y plus 6. Okay, so I did it. I isolated one of the variables. Okay, again, I would choose one where the coefficient is 1, like it is here. Okay. You don't have to, but it will definitely make it easier for you. Okay, now what I'm going to do is, after I did this, now that I know x equals negative 2y plus 6, I'm going to substitute it into the other equation. So since I used x plus 2y equals 6 to get this, I'm going to plug it in to this equation here. Okay. So 3 times x is negative 2y plus 6 minus 4y equals 28. Then I'm going to just solve for y. So distribute. This gives me negative 6y plus 18 minus 4y equals 28. I'm going to combine like terms. Negative 6y minus 4y is negative 10y. I'm going to get rid of the plus 18 by subtracting 18. I'm going to get rid of the times negative 10 by dividing by negative 10. This gives me y equals negative 1. Okay. And now that I know y equals negative 1, I'm going to take it and I can plug it in whichever one I want, whichever y value. Okay, so technically you could plug it in here, here, or since this one already has y here and x on itself, I'm going to plug it in right here. So x equals negative 2 times negative 1 for y plus 6. Okay. Negative 2 times negative 1 is positive 2. So x equals 2 plus 6. 2 plus 6 is 8. So x equals 8. And so I have my solution 8 comma negative 1 because x equals 8 and y is negative 1. Okay. And then if you want, you can check it by plug it back into the original and seeing if it's true for both. Okay, so let's flip. Okay. Let's try another one. Okay. So here, I want a variable by itself. So y here is already by itself, so I'm good to go. Right, so I can move on to step 2. Okay, so I'm going to plug it in here for the other equation. So negative 6x plus 3 times, instead of writing y, I know y is 2x minus 4, so I can substitute it in. Then I just need to solve for x. So I'm going to distribute here. 3 times 2x is 6x. 3 times negative 4 is negative 12. Okay. Then, combining like terms, negative 6x plus 6x is 0x. So that means I have no more x's. And all I'm left with is negative 12 on the left side and negative 12 on the right side. Okay. And again, same thing as when we were solving equations before. If we have a true identity statement like this, where it's negative 12 equals negative 12, 4 equals 4, 1,000 equals 1,000, something like this, when we arrive at an identity statement, what that means is that we have infinitely many solutions. It means that any point in this line is true. Okay? This does not mean, in this case, it is not all real numbers. Okay? And what we can see is that if we graphed this, okay, this would be the exact same line. Both of these are the exact same line. Okay? So let's try another one. So here I have 2x minus y equals 8, and here I have y equals 2x minus 3. So since this one already has the variable by itself, I'm going to take this, since y equals 2x minus 3, I'm going to replace the y in the other one with that. Okay? So 2x minus, okay, so y is 2x minus 3. Right? So make sure that it's in the parentheses because we need to distribute the minus to all of it, right? Because it's minus all of y, and all of y is 2x minus 3. Okay? Equals 8. Okay? So I'm going to distribute. Okay? So negative 1 times 2x is negative 2x. Negative 1 times negative 3 is a positive 3. Okay? Then I'm going to combine like terms. 2x minus 2x is 0x, so I'm just left with 3 equals 8. This is a false statement. This is not true. And so similarly to when we were solving equations, what this means is that there is no solution. If we were to graph these, we would see that they are parallel lines, okay, and that they do not intersect at all. So that's it for today. Have a great rest of the day. Bye, guys.